Okay, this is a quick thing on the preparation I did for the course so far. We're combining two courses, 8 hours, into a 4.5 hour course, which is going to make this course incredibly intense. On the other hand, most students took both of them at the same time, so maybe it'll just simplify things. So, when I put this course together, there are a few things that we're doing uh, that need to be done. Much of it I can just use, since I've taught both courses in the past, I can just more or less use what I've taught before. But since, like I said, there's less time, I'll probably have to simplify. But since it's a new textbook and a new course, I decided to jazz things up a little. So I decided to, since the textbook didn't have a microcode it was describing, I decided to bring in a free microcode simulator called Myth, M-Y-T-H, Sim, S-I-M, and teach using that. It's free, it's a jar file, so it runs on PCs and Macs, and it will give students an idea. But I've learned that you can't actually, I just know. I never even thought that it was a good idea to try to do it. I always try to program in a language before I try to teach it. Now, MythSim takes a microcode language, and it's a program for machine code, understanding machine code. So the idea is to develop machine code. So the first thing I did was, since the last machine microcode I taught using the Tannenbaum book was a stack architecture, I decided to see if I could put a stack architecture on MythSim. MythSim doesn't like stack architectures, it's not designed around it, but I forced it, and I did. And I got something that I think mostly works. I haven't debugged every last little part of it. I was able to get programs to run, to loop, to access memory, to access the stack, pushing, popping, some arithmetic, swapping between registers. I got all of that working. Then I decided to build an architecture that actually fits this device. I call it the default architecture, based on some examples I picked up on the web. And I make that work too. This one I've actually tested more, although I haven't tested, say, the XOR instruction. But I've tested most of them. Had some funny experience with subtraction, it turns out. Subtraction is defined as adding not, and I have to throw Cn in to make sure it adds not plus 1, so it actually subtracts. But anyway, that might be useful when I teach 2's complement next class. So, that is what I have to say about prepping for the new architecture course.